Hey guys, how are you all? Hi everyone. कैसे हैं सब लोग? After a long time, how is everyone? कैसे हैं सब लोग? कितने students हैं क्लास में already? Namaste, namaste Anmol. Where are the Mogambo army people? Where are Mogambians? So guys, one thing first in the beginning, it's been a long time, so obviously I want you people to quickly spread the word that Mogambo is back and we are going to have our session. Yes, we are back again, and yes, after a long time, Rambo is back. Yes, Shinchan, I'll try my best. Very nice, very nice. I'm good, Himadri, I'm good. Yes, Shinchan, I heard you. How are you people? कैसे हैं सब लोग? How are things, people? I guess a lot of students have been busy watching IPL. हाँ, IPL तो देखना शुरू नहीं कर दिया सबने. I'm good, Anmol. I'm good, guys. I'm good. Had some family medical emergency. That's why I was not coming live, but everything is all right. Thank you, everyone, for all the support, all the prayers. Thank you so much, everyone. Yes, definitely, Ravi. Yes, Pratham, this is very first lecture of Waves. Hi, Krishnendu. Hi, Shalini. Hi, Tanu. Hi, Jagdish. Hi, Rabia. Aha. Hi everyone, I hope all of you are doing fine. Good to see you all after a long time. कैसे हैं सब लोग? Hi Abhishek, hi Ayush, hi Swati, hi Shivani, Night Owl. Yes, Night Owl, that's good. Very nice. Okay, proud to be an Indian. NEET aspiring students can also attend my sessions. Okay, not a problem guys. सब लोग attend कर सकते हैं. I'm good. I'm good. Thank you so much everyone. Thank you so much for asking. Okay. Yes, Patel Dev. Um, Almost all the topics that we are covering the most important part which is required from JEE point of view. Okay, don't worry. Great, yeah, great. So guys, quickly spread the word. Tell your friends. WhatsApp पे share कर दो, social media platform पे share कर दो कि class start होने वाली है. Okay, very nice, very nice. Good. So all those people who are new on the channel, कितने लोग नए हैं? I would like to know that quickly. How many of you are on the channel new? How many of the people in the class right now are new in the class? कितने लोग नए आए हैं क्लास के अंदर? Quickly tell me. JEE channel is this. This is JEE channel, Ankit. Haha. Okay, a lot of students are new. Pratham is new. Pinchan is new. Rabia is new. Ansh is new. Very good. Jaideep is new. Jagdish, I'll try my best because students are from all the parts of the country, so I'll try to keep it at least Hindi plus English. English is what we call it. Mostly academic part is going to be in English, don't worry. Okay, that's good, guys. So for all those people who are new on the channel, let me start off with my introduction. So guys, this is me, your Suri Sir. I am a pass out of IIT Bombay from 2009 batch, and on this channel my students call me Mogambo, and all the students are called Mogambians. Why? Because when you are going to crack this examination of JEE, Mogambo khush hoga. Okay. Hi Ravi, very good, welcome. So guys, if you are new on the channel, then definitely I want you people to subscribe to the channel right now. Press the bell icon. अगर नए हो channel पे तो अभी के भी channel को subscribe कर लो, bell icon को press कर लो, so that whenever Mogampo is coming live with any of the sessions, you are not missing out on any of those. Okay, people, that's great. Very nice, very nice. Okay, apart from that, if you want your JEE preparation to be even more strengthening, tell me one thing, guys. How are you guys preparing in this phase? Is lockdown affecting you people? Is this corona time affecting your JEE studies? Tell me in the chat box. Is it affecting your JEE studies? क्या जेई की स्टडीज अफेक्ट हुई हैं? आप क्लासेस नहीं जा पा रहे हो, स्कूल्स नहीं खुल रहे हैं, schools are not opening. So is this difficult lockdown phase which has it been a difficult phase for all of you guys? Yes, exactly. Okay. So some of you are saying no, some of you are enjoying this phase, some of you are saying yes. So if you are a serious JEE aspirant, अगर आप JEE को बहुत seriously prepare कर रहे हो, तो even at your home, in the comfort of your own houses, you can continue your JEE preparation, guys. You don't have to actually step out. You can study for JEE examination within the comfort as well as safety of your own houses. How is that possible? Let me share that information also with you all. So guys, you can study on Vedantu's own platform, which we call as Wave, under a subscription plan called as Vedantu Pro. So whenever we join anywhere, whenever we join any classes anywhere, what exactly we expect? हम expect करते हैं कि हमें teachers class में आके पढ़ाएं. We expect teachers to teach us in the class. We expect regular testing and test series and analysis to be shared with us, and we expect study material to be provided. So definitely that will be provided with to you guys when you join Vedantu. Yes, when you join Vedantu under subscription plan Pro, it's not a course, it's not a batch. Okay, Vedantu Pro is not a course or a batch. It is more of a subscription plan. What makes it one-stop solution is what I want to share with you all. So when you join Vedantu with Vedantu Pro subscription plan, you become a part of a long-term batch and you complete your entire JEE or NEET syllabus. Yes, for either JEE or NEET, जो भी exam आप prepare कर रहे हो, any of the examination preparation continues. A lot of teachers are there, your master teachers, who will be constantly in touch with you to make you prepare best for your JEE examination, NEET examination. You have access to a lot of questions, around 10,000 plus questions. A repository is there for you to access it. You can learn in Hindi or English, or you can also attend any course which we call as the micro course, depending upon your requirement. We will never ask you to watch any recorded sessions. You can always attend a live micro course. Yes, it is worth, Akshay. In fact, there are trial bases also. You can go for that also. And later on, when your exam comes, you become a part of a crash course and test series. Separately, you don't have to join anything extra. You become a part of a test series, you become a part of a crash course naturally. Okay, whenever you want to revise any chapter, you can attend live micro courses at Vedantu, chapter wise courses. Okay, and this is how, by the way, the platform looks like. This is how the Wave platform looks like. Coincidentally, today we are teaching, I'm going to teach you all the chapter of Wave, but this is the Wave platform. This is how teacher is teaching. This is Pulkit sir teaching in a class. This is where students are interacting, they are asking their doubts, and as I said, everything is happening live. So if you are interested in joining, all the 2022 students, that means all the students who are right now in 11th standard, guys, you can join depending upon your requirement. You can try in the beginning. If you are not very sure about the online teaching, you can first experience the platform. If you have already, you can go for a longer subscription plan. Obviously, longer be the subscription plan, more is the savings of the per month cost that you are going to pay as the fees. Okay, and the link for joining is available in the description box. It is vdnt.in/ytpro. Okay, Jyoti, you can join. Don't forget to use this coupon code SMPRO. The link is available in the description box. It is vdnt.in/ytpro. You will be able to join by following this link in the description box. And if you are a repeater student, if you are taking a drop for JEE 2021, then also we have a batch which has started on 21st of September, and the same coupon code, and enroll now. So steps are very clear. Select your grade 11th, 12th or 13th. Select your subscription plan. Go to make the payment, and before that, make sure that you are using the coupon code SMPRO and enroll now. Okay. Yes, Akshay, these are all same courses for CET examination. कोई भी एग्जाम के लिए प्रिपेयर कर रहे हो, सारे courses available हैं. Okay, so any exam that you are targeting for, you are going to get your preparation for any competitive examination that you are targeting for. Okay. Okay, YouTube, as far as your lectures are concerned, as far as theory is concerned, as far as little bit of problem solving is concerned, you can actually prepare a good deal about JEE on our YouTube platform also. But you know that ki JEE is an examination where you're required to do a lot of self analysis by appearing for as many tests as you can, and for that you need a platform. And what better than an online platform like Vedantu? where you can actually appear for online tests, see your own performance analysis, and get to know where exactly are you going wrong or your strength areas as well. So that is why the online platform is required for that. Okay. Okay, Akshay, thank you. So guys, let's start the topic of wave motion. आज पहला session है. This is our session number 1 on waves. We'll be speaking about wave equation, wave speed for strings and sound. So if you guys are ready, if you guys are good to go, just give me a yo in the chat box quickly. Come on guys, give me a quick yo in the chat box if you guys are ready, if you are able to hear me, if you are able to see me, and you guys are ready for it. Okay. मैं ठीक हूँ एकदम नितिन, thank you for asking. Yes, this is the very first lecture, Isha. This is our session number 1. Thank you, Nitin. I'm good. Very good. Okay, Isha. Yo, yo. Very nice. That's awesome. Chalo, guys. So, start karte hain. Let's first understand what exactly is a wave. Right now, the animations that you guys are seeing, all these animations are telling you that there are multiple springs. ऊपर वाले animation की बात कर रहा हूँ. If you guys will see and look at this very first animation here, you will see that the first animation has so many springs which are oscillating, which are doing simple harmonic motions. And the particles which are connected, or the masses which are connected at the bottom of those, look at their motion. Their motions are all oscillatory motions, but they are not oscillating in the same phase. By same phase means not all of them are crossing their mean positions together, not all of them are reaching their extreme positions together, but there is a pattern in which these oscillations are taking place. Yes or no, guys? All the particles which are oscillating, they are oscillating and creating a pattern in such a way that if you expect some kind of disturbance to be created on the left side, that disturbance appears to be moving towards the right side or vice versa, right? This transfer of disturbance, this transfer of energy, this transfer of momentum from one point in the space to the other point is what we call as wave. And wave is an interconnected chapter to the previous chapter that we have studied called as oscillations or simple harmonic motion, and one of the easiest, if understood well, and one of the most interesting chapters of mechanics it is. Okay guys, so let's start off by understanding what are the different types of waves. We have already talked about the definition. Wave is nothing but disturbance of different forms in which energy is going to get transferred from one point to another. Now, depending upon whether there is a requirement of a medium for energy to travel from one point to another, okay, whether there is an energy which is getting transferred and there is a medium which is required in between or not, we are going to talk about two different types of waves. Okay, so what you see here, depending upon the requirement of medium, we call one of the types of waves to be mechanical, and second type of waves are called electromagnetic waves. Okay, mechanical waves are the one which are going to be discussed in this particular chapter because we are studying mechanics. Okay, so हम लोग mechanics पढ़ रहे हैं, so that is why we are going to speak about the mechanical waves. And what exactly is a mechanical wave? A mechanical wave is the wave which is being created and existed in a material medium. Means whenever for the transfer of energy from one point to another, if you require a material medium, means what? If you require air, if you require water, if you require a solid, if you require a liquid, if you require a gas, then that type of wave is what we call as a mechanical wave. Can anyone tell me any example of a mechanical wave in the chat box? Hi Anjali. Can anyone tell me example of a mechanical wave in the chat box? Mechanical waves. Yes, thank you, Roshan. Yes, sound wave is. Guys, am I properly audible to everyone? Am I properly audible, everyone? I'll pull the microphone closer so that I'm more clearly visible to everyone. Yeah, thank you so much for the feedback, everyone. Stone thrown in water, exactly the ripples which are created. Look at the example which is already there. Thank you, Mithun sir. The stone which is thrown in water, it creates ripples in water, and that is another example of mechanical wave. And look at what this guy is doing in the gym. He's pulling the string up and down, because of which a wave is created, right? Exactly. Hi Anjan, welcome. So guys, tell me one thing. These are the waves which require a material medium, so we are calling them mechanical waves. But then there are waves which do not require any material medium for their propagation. Any example of such waves? Electromagnetic waves का कोई example? The best example is, yes, best example is light. Yes guys, you know that sun से लेकर earth तक पूरा एक electromagnetic spectrum है, which comes without even being any medium in between. It is completely vacuum. Yes, Dhruv, thank you for the response. Okay, so guys, best example for mechanical wave is sound, or the one that you guys told me, or you can say string wave also. Electromagnetic waves के case में light, UV rays, ultraviolet rays are the UV rays, or infrared rays, or X rays, or cosmic rays are your electromagnetic wave. Now, as I said, in this topic, in this chapter, we are not discussing the electromagnetic waves. We will have that discussion in 12th standard. Okay, after we are done discussing electric field and magnetism, we'll discuss electromagnetic waves in 12th standard. Okay, okay. So this is the chapter where we are going to discuss the mechanical waves. And in mechanical waves, again, there are two types of waves. The first one, as you can see it on the screen, are basically your transverse wave. What are you looking at here is a person with the help of his hand. He is just making his hand move up and down, because of which a disturbance is created in the spring. So what is this person's hand behaving as? This person's hand is behaving as a source. Okay, so waves के creation के लिए एक source की requirement है. There is a requirement of a source for a creation of a wave, and that is what is happening here. And once a disturbance is being created by the source, the disturbance is being traveled by the medium. Okay, means medium particles, how they, what exactly they are doing, they are trying to replicate the motion of the source is moving like this, all the particles are doing in the same type of motion, but not at the same time. So what is happening in the case of a transverse wave? A transverse wave is the one which is in which the wave propagation is perpendicular to the direction of the oscillation of the particles. Means what? एक ऐसी wave जिसके मूवमेंट के दौरान मीडियम के पार्टिकल्स उससे परपेंडिकुलर ऑसिलेट करते हो, उस वेव को हम बोलते हैं ट्रांसवर्स वेव. Okay guys, and what exactly gets created here? It is in the form of crest and trough. Okay, crust is the upper portion, trough is the lower depression. Okay guys, so whenever there is a wave, when you can see a wave is propagating, you can see here also wave is moving along x-axis, and your medium particles are oscillating along y-axis. So when the medium particles oscillate perpendicular to the wave propagation, then the wave is what we call as transverse wave. बहुत simple form में अगर याद रखना है, तो transverse wave is the one which has crust and trough being formed. Crust is the upper cycle, trough is the lower cycle. Okay. Hi Baji, welcome. Welcome to the session. Okay. Yes, Roshan, you are right. In a moving wave, I should not represent that. Okay. Second one is a longitudinal wave. Now, what is a longitudinal wave? Look at the difference here. The particles are oscillating in the x direction, and the wave is also propagating in the same direction. So again, your source is oscillating along, say, horizontal direction, and the wave is also being created in the same direction. So whenever your medium particles are oscillating in the same direction or in the same line, that is the direction of the propagation of the wave. That is basically what we call as a longitudinal wave. And here, what you see, these small portions of the medium where medium particles are closer, they are basically called as compressions, when medium particles come closer, and the other one where they go away are called as rarefactions. Okay guys, so what you are seeing here, your medium particles are basically trying to replicate the motion of the source. That means what? multiple SHMs, multiple oscillations when they are taking place, and that too in an order, is what creates a wave. What exactly is a wave? A wave is basically combination of multiple SHMs, and that is what is going to get reflected when we are going to speak about the wave equation as well. This is one of the super cool visualizations that I'm sure will help you. Okay. Yes, Chandrasekhar, I'm sure you will. You will crack this examination. Hi, Anjan, I'm good. Thank you for asking. Yes, Chandu, you are right. Okay, guys, so what you see here, the wave is trying to move in the form of ripples in all possible directions, and medium particles are oscillating maybe perpendicular to it or maybe along the same direction depending upon which wave you are talking about. So if you think of it as a sound wave, the ripples are moving in xy plane and the medium particles are also oscillating along those lines. Okay, that's nice. Okay, so now let's speak about the wave characteristics. As you know that wave can only be created because of a source oscillate karega to wave ka creation hoga. So that is why there are certain characteristics which we need to speak about. First one is with what we call as wavelength. What exactly is a wavelength? So if your wave is traveling with a speed v, then the distance between the identical points on consecutive waves is what we call as the wavelength. That means what? Say if you have a point which is at crust right now, when you see the next consecutive crust, the gap between these two consecutive crusts or the two consecutive troughs is what we define as one wavelength. Or you can say the gap between two successive particles whose motions are identical. The particles which are replicating each other's motion, gap between them is what we call as one wavelength, represented by lambda, and obviously unit will be yes. Yes, Chandu, you are right. That will be measured in meters. Okay. Second one is what we call as amplitude. What is amplitude? As I said, somewhere here is your source, which is going to oscillate at its own position, and your wave will also be created because of oscillations of particle. The maximum displacement which is suffered by the source as well as the medium particles during the propagation of the wave is what we call as the amplitude. So amplitude is nothing but the maximum displacement from the mean position. This is your line of mean position here. Okay. And what is frequency? We all know frequency is nothing but number of cycles per second. So how many number of times your source is oscillating in 1 second will also become the frequency of your wave. Okay. Always remember, amplitude and frequency are given to a wave by a source. The source which is creating the wave, be it light source, be it the string waves, whichever, not the light, the sound one, sound wave, or the water waves or the string waves, the source which is oscillating continuously, whatever is the amplitude, whatever is the frequency of the source is going to become the same for your waves as well. Remember that. But on the other hand, when we speak about wave velocity, we haven't spoken about that yet. The wave velocity is going to become the function or something which is going to depend upon the medium here. Okay, guys? Okay, that's correct. Let's try to understand this with the help of a super cool visualization. You can see how amplitude and wavelength variation and the phase variation is taking place here. So have a look at it once again, guys. What happens here when you have variation of amplitude taking place? You can see the amplitude is changing. This is where the wavelength is changing, the gap between two identical particles, and phase differences between two different waves or two different particles which are trying to replicate each other's motion after a certain gap of distance or certain gap of time. Okay, cool. Yes, guys, great. Now let's speak about wave velocity. So when you look at this animation, kangaroo can be seen as the disturbance which is traveling. मतलब इस kangaroo को बिल्कुल एक disturbance और एक energy के packet की तरह देख सकते हो which is traveling along x-axis. But look at the frequency and the wavelength being different here, right, guys? So the wave velocity is basically the velocity with which the kangaroo is moving on the right hand side. And how do we do that? How do we find that? Yes, Chandu, thank you so much. So we define the wave velocity as the distance traveled by the wave. Say lambda is the distance traveled, and in how much time that will be traveled. will be traveled in a time of capital T. What is capital T? It is the time period. What is time period, guys? Time period is basically the amount of time taken by your wave in order to get created completely. One wavelength, the amount of time which is taken by the source to create one wave is what we call as the time period, or you can say the time in which source oscillates once. For one oscillation, the time which is required. Yes, Jyoti, thank you so much. Yes, we can write that also. So if we write time period, can I say time period we can write as 2 pi by omega? We can write that also. What is omega? Omega is the angular frequency. So this becomes lambda upon 2 pi into omega. And lambda upon 2 pi or 2 pi by lambda is what we call as k. So V can be written as omega by k as well. What is k? K is 2 pi by lambda. We call it wave number whenever required. So both the formulas are valid. V equal to lambda by t. We can also call it V equal to n lambda. V equal to n lambda or f lambda, whichever you want to call it. You can call that also, as so many of you know this formula. Okay, you can call this also. Okay, that's good, guys. Very good. Okay, cool. Now, how about the equation of simple harmonic wave? A simple harmonic wave equation is going to be the wave equation which is going to represent the oscillation of each and every particle simultaneously. So the equation of wave is written as y equal to a sine omega t, either minus kx, or it is also written as y equal to a sine omega t plus kx. Okay, I'll tell you when plus or when minus sign comes in, but before that let me tell you what is happening here. This equation is telling you how different particles are oscillating at a given time or at a given location. If you keep t constant, then different particles at different x locations, how the image is being created is what you can find by using this equation. And if you want to talk about a particular particle at a given distance x, then you will fix x, you will keep on changing time, so its oscillation can be found here. Okay, so guys, what we have here is the equation of the wave, which is y equal to a sine omega t minus kx or plus kx. When you have a negative sign, this tells you wave traveling in positive x direction. Always remember that. Whenever your wave is traveling towards positive x direction, you will have a negative sign here. And if your wave will be traveling towards the negative direction of x, this is a wave which is traveling towards negative x direction. Please remember this. When you have a minus sign here, the wave is traveling towards positive direction. And whenever you have a plus sign here, the wave will be traveling towards negative direction. You can trace it by finding the wave velocity also. Okay, or we can put different values of t here, different values of x here. We'll find that the wave is found to be traveling in the positive or negative direction according to the requirement. Okay, cool, awesome. Now when we speak about the string waves, what is the velocity of the strings waves when they are in the stretch string? So we are going to speak about two waves here today. We are going to find the velocities of the two waves here. Okay, what are we going to find out? We are going to find out the velocities of the strings in a wave, waves in a string, sorry. And the second one we are going to find out is what happens to a sound wave. Sound wave की velocity पता लगाएंगे और string wave की velocity का expression लिखेंगे. So the string waves expression is given by under root of t by mu. This is the expression of velocity of string waves. What exactly is t? T is the tension in the string. And what is mu? Mu is mass per unit length. Okay, this expression can be derived by using string motion, or you can also find it out by using dimensional analysis. Okay, you can try that by dimensional analysis. Why am I not getting into the derivation? Because that is not important either from JEE or from your school examination point of view. Okay, that is why. Okay. Yes, this is the very first session, Nayana. Okay, guys. So can you keep this expression in mind? Under root of T by mu. T is the tension in the string. Mu is the mass per unit length. This will be the formula for the string waves when the waves are traveling in a string. Okay. Okay, guys. Now, when we speak about a longitudinal wave or a sound wave, for the sound waves, the velocity of the waves is defined to be under root of E by rho. What exactly is E? E is something which we call as modulus of elasticity, which we have not studied it yet. We'll study it in a chapter called as elasticity. अभी हमने उसके बारे में बात नहीं की है. Okay, and rho is the density of medium. So whichever medium your wave is propagating, sound wave is propagating in solid, liquid or gas, depending upon that, the modulus of elasticity will be put, depending upon the density of the medium will be put, and the velocity of the sound wave can be found. Okay. Okay. So when we talk about the speed or the velocity of the sound, there were two formulas which were given. First was given by Sir Isaac Newton himself. When he talked about propagation of sound, he assumed that sound propagation is an isothermal process. Okay? When we say isothermal process, he assumed that when sound travels from one point to another, there is no temperature change in the medium. Okay, I hope you guys understand what is this isothermal process. नाम सुना होगा पहले भी. So when he assumed so, he calculated the speed of sound as under root of E by rho, and E value in isothermal process comes out to be the pressure of the air. Okay, obviously we try to find out the speed of sound in air here. So the pressure is 1.01 into 10 to the power plus 5, okay, Newton per meter square, and density of air is 1.29 kg per meters cube. So when we put these values, okay, both the values, he found out the value of speed of sound, which came out to be close to 280 meters per second. That too in air. But later on, with practical results, it was found that the value of speed of sound in air is not 280 meters. Okay, so later on, another scientist, Laplace, came up with the explanation. He suggested that propagation of sound is something called as an adiabatic process. What is an adiabatic process? Again, something that we will learn in the chapter of thermal physics or thermodynamics में हम ये चीजें पढ़ेंगे. अगर chemistry में पढ़ चुके हो तो that's good. If you have not studied it in chemistry, don't worry, we'll study it in physics. Adiabatic process is the one where we are not going to give or take any heat from the medium. Okay? So when that happens, the elastic modulus of elasticity comes out to be something called as gamma into P. Okay. Now again, what exactly is gamma? Gamma is what we call as the ratio of molar specific heat at constant pressure and constant volume. As of now, you guys just focus on the expression here. When we put this, okay, so gamma value for air is 1.41. Pressure and density is already known. So when we put the value of pressure as 1.01 into 10 to the power 5 Newton per meter square, density of air as 1.29 kg per meter cube, जब ये values हम put करते हैं, so the value of speed of sound nearly comes out to be 330 meters per second, or close to 332 meters per second it came out by Laplace correction. Okay, that too in air. Okay, so what I want you people to keep in mind, that the formula for the speed of sound according to Newton, that formula was under root of P by rho, and according to Laplace correction it was gamma P by rho. And later on we'll study something called as ideal gas equation, PV equal to nRT. So when you do that, it will be gamma RT by M. Okay, very good, Roshan. Yes, I can see many students are already aware about a lot of things related to thermodynamics, maybe from chemistry. If not, then that is still fine. remember the correct formula was given by Laplace here. Okay, good guys. Now based upon what we have learned, we'll do the examples also. This is the usual trend. Always remember, velocity of sound in solid is going to be greater than the speed of sound in liquid and greater than the speed of sound in gas. So sound will travel faster in solids and slowest in gases. Okay, cool. Are you guys ready for examples now? I hope you guys are. Let's solve some questions based upon what we have learned today. Okay, good evening Nishant, welcome. चलो guys, तो question solve करते हैं. First question, it says that a 5.5 meter long string has a mass of 0.035 kg. If the tension in the string is 77 Newton, the speed of the sound will be how much? So V will be equal to under root of T by mu, as I said. Okay, mu is mass per unit length, so we'll put that accordingly. So tension in the string is 77, mass is 0.035. So what I'm going to do, I'm going to make it easier for us to do the calculations. I'm going to write it as 3.5 into 10 to the power minus 2 kgs divided by the length, and length is 5.5 meters in under root. So when I divide this, first of all, decimal taken care of, 5 cancels it 11 times, cancels this 7 times. So I have 11 into 11 into 100 in under root. That comes out to be 11 into 10, or simply 110 meters per second is the speed of sound, sorry, speed of the wave in the string whose tension and mass per unit length is what we found. Very good, Sai. Very good. Awesome. I don't know Mamta, but you can visit Vedantu by visiting vedantu.com. Okay. Okay. Okay, Roshan, you can solve along with me. Next question, guys. A wave is represented by this equation: a sine 15 pi t plus 10 pi x plus pi by 3. Can you tell me what is omega here and what is k here? By comparing the equations, can you tell me the value of omega and k? No problem, Hariom, it's okay. Yes, Anjan, you can make the notes along with it and you will get the PDF of the session that I'm taking. Session के notes मिल जाएंगे. Okay, don't worry. I'll tell you towards the end. Yes, so when you compare this by y equal to a sine omega t plus kx plus phi. Okay, let me write it here once again. So when you write the value and compare, you can see that this is going to be 15 pi, which is omega, और k का वैल्यू हमें मिल जाता है 10 पाई. तो इक्वेशन बन जाती है y इक्वल टू a sin omega t plus kx plus phi here, और phi का वैल्यू pi by 3. Thank you, Sakshi. Now what you see here is a plus sign. So is wave traveling towards positive direction x or negative direction x? I told you people how to keep it in mind. If there is a plus sign, whether the wave is traveling in positive direction or negative direction of x. Yes, Jagdish, you're right. Whenever we see a plus sign here, wave is traveling in negative x direction. So definitely answer is not A. ठीक है, तो आंसर या तो B या ये C होने वाला है. Let's see. Both 2 and 3 are also there as an option. So let's try to find out the wave velocity. Wave velocity is omega by k. Omega is 15 pi, k is 10 pi, comes out to be 1.5 meters per second and traveling towards negative x direction. So definitely option B is correct. Also, let's check the value of wavelength. So lambda is 2 pi by k, which is 2 pi, k value is 10 pi. This comes out to be 2 by 10 or simply 0.2 meters, and that is also telling us to be traveling in negative x direction. So both B and C are correct, so the more appropriate answer is option D. Okay, yes, that's great. That's nice. Very good, guys. Very good. Chalo, let's go to the next question quickly. A transverse wave of amplitude 0.5 meter and wavelength is given, frequency is given, is propagating in a string in the negative x direction. So the equation will be negative x direction. So definitely it has to be a plus sign in between, right guys? So A and C cannot be the correct answer, right? So we need omega and we need K. So how will I find omega? Omega will be 2 pi by T or 2 pi F, which is 2 pi, frequency is given as 2, so this is 4 pi, right people? And K is 2 pi by lambda, that is 2 pi divided by 1, that is 2 pi only. So Y will be equal to 0.5 sine omega t, and Kx is there. So K is 2 pi x and plus 4 pi t. That's the equation that I'm getting, which is option B. Guys, यहाँ पे 2 pi t है, हमें 4 pi t लेके आना है, right? A cannot be the answer because this is a minus sign, so this wave is traveling towards positive x direction. We need a wave traveling towards negative x direction. Okay? Yes, you are right. Very good, Ivy. Cool. Moving on to the next one. The velocity of a sound is Vs in air. If the density of air increases 4 times, the new velocity of the sound will be keeping the pressure constant. So if V is gamma p by rho according to Laplace, the velocity of sound, then you can see V is proportional to 1 by root rho, under root of rho, right? So V dash by Vs is equal to under root of rho by 4 times of density, which comes out to be 1 by 2. So V dash kitna aa jata hai? Vs by 2. That means answer is option A. Very good, Ankit, Simpi, Chandu, Sai, Ivy, Navneet. Answer is A. Very good, everyone. Very good, Vedant. Awesome, guys. Awesome. Keep it up. Next one. The ratio of density of nitrogen and oxygen is given to us. The temperature at which speed of sound in nitrogen will be same as that of oxygen, and oxygen is at 382 Kelvin. So velocity of sound is under root of gamma RT by M. I told you, right? So V in nitrogen is same as V in oxygen. So gamma is same for both the gases. R is same for all the gases. So it is going to be T by M, which has to be same. So T by M for nitrogen has to be equal to T by M for oxygen. Temperature is what we are trying to find out for nitrogen. My molecular mass of nitrogen is 28. Temperature is 328. Always put it in Kelvin. And mass of the oxygen molecular mass is 32. So T dash is 328 by 32 into 28. When we simplify this, it will come out to be 287 Kelvin. Okay, or we can say T dash is going to be 14 degree centigrade. Okay, so no problem. Calculation is something which is new for all of us. Okay, this will come out to be 287 Kelvin क्योंकि molecular mass कम है nitrogen का, तो temperature भी कम होगा to have the same ratio. Okay, I'm good, Atharva. Thank you. Okay, this is the condition given. So here omega and R are same, so T by M has to be same here. Okay, very good, Navneet. Cool. Moving on to this one. A transverse wave is given by this equation. The maximum particle velocity is equal to 4 times the wave velocity. So V max during SHM is A omega and V wave is omega by K. दोनों equal हैं. According to question, A omega is equal to omega by K, and this cancels. Okay. So A, and this I can write as 2 pi by lambda. So I can say lambda will be equal to, sorry, these are not equal. A omega is 4 times this value according to question. My mistake. This will be 4 here. This comes out to be 2 lambda by pi, and lambda comes out to be half of pi into A. Getting it, guys? Answer is option B. Very good. Hi Ankur, welcome. Welcome to the session. Awesome. Okay, Atharva. Good to know that. अच्छा लगा. Hope it helps you. Okay, Atharva. Chalo, moving on to this one. Speed of sound in mercury at a certain temperature is this much. Density भी हमें दी हुई है. Bulk modulus पूछा है. तो speed of sound का formula B by rho. Bulk modulus by density होता है. Again, something which is new for us because we haven't studied thermodynamics. Not a problem. You will study it. तो rearrange करने पर formula ये बनेगा. When you will put the value of P as 1450 and density as 13.6 into 10 to the power 3 for mercury. We will put these values here. We will get the answer as option A, leaving it for you guys to try as a homework question. Okay. Next one, tuning fork makes 256 vibrations per second in air when the velocity of sound is given. So V will be equal to F lambda. Question में lambda पूछा है, which is going to be V by F. V is 330, frequency is 256, so lambda comes out to be 1.29 meters. As simple as that. Okay, very good, guys. We'll take mechanical properties of fluids, don't worry. After this, we'll be studying fluids as well. Okay, homework question for all of you. Have a look at it. Okay, do take a screenshot, everyone, and try to solve this question. And where are you going to tell me the answers? Tell me the answer that you are getting in the comment section of this video. Okay. Okay, and I will get back to you guys with the correct answer as well. Okay, cool. So guys, if you are new on the channel and want to know how to cover up, जितने भी नए students हैं, if you want to know how to cover up the missed topics, I have two solutions for all of you. I'll share that quickly with you because 8 o'clock I have another sessions with you guys. Okay, so guys, one way is to go to the channel playlist, look for this channel playlist, JEEt Lo 2022, and the other way is to come for Vedantu Pro, where you get to attend live chapter wise course for revision under something which we call as micro course. तो हम माइक्रो कोर्स के थ्रू ही पूरा रिविजन कर सकते हैं. ऑल यू हैव टू डू गाइस, go on the link that is available in the description, choose the subscription plan depending upon your requirement. Okay, and use the coupon code SMPRO to get an additional 20% discount. This is for 2022 student, 2021 or students who are taking a drop. जितने भी students जो JEE 2021 लिखना चाहते हैं in the month of January, they can also join a separate batch for droppers by using the same code SMPRO. All you have to do, guys, is go on the link which is available in the description box and you can be a part of our स्पेशल ड्रॉपर्स बैच ऑल्सो. और जितने भी लोग अभी तक फ्री ऑफ कॉस्ट टेलीग्राम ग्रुप पे नहीं हैं और आना चाहते हैं to get the assignment solutions, study material and daily updates, you can do that by again following this link available in the description box. Okay guys, so after a long time, felt good to be in the class, okay, with you all. Thank you so much for coming guys. अगर सेशन में मजा आया तो do press the like button, share with your friends and subscribe to the channel right now and press the bell icon so that whenever Mogambo comes live you get the notification. Okay people, so on that note I'll take your leave. I'll see you sharp at 8 p.m. with EMI quiz. Okay, 8 बजे वापस आ जाओ. EMI quiz करेंगे, electromagnetic induction. Okay, for all the students who are in 12th standard or are taking a drop, 8 o'clock, I'll see you there. Okay, bye bye guys, take care.